Okay, these are your notes for section 610, and we're going to analyze solutions to quadratic equations today. And you're going to find this section is pretty nice because what we are able to do is to figure out how many solutions there are going to be just by looking at a part of the equation and not doing the whole quadratic formula. Okay, discriminant. This is the word that you're going to need to know today. Basically, when you have the quadratic formula, you know x equals negative b plus or minus square root b squared minus 4ac. Over 2a. Okay. The value under the square root sign is called the discriminant. This b squared minus 4ac. Okay? This value will tell you how many solutions you're actually going to have, or how many times the parabola hits the x-axis, because you have three things that could possibly happen. Your parabola could look like this. There are two solutions. It could look like this, and then there are no solutions because it will never equal 0. Because remember, it has to equal 0. So there's two places where it'll equal 0. Here there are no places where it equals 0, or it could look like this where it is tangent, and then there is one solution. Okay, so we are going to take a look at how we can use this piece, this b squared minus 4ac, to determine how many solutions our quadratic has. Okay, this is what I would jot down in my notes, and I really think that the picture is going to be enough. This is case 1. If b squared minus 4ac is positive, when I take the square root of that, I'm going to get a positive number. Okay, so this is positive, b squared minus 4ac. This is going to be positive. When I take the square root of a positive number, I'm going to get a positive number. So I'm going to add something to it. I'm going to subtract something from it. I'm going to get two different answers. So if b squared minus 4ac is positive, you are going to get two real solutions that I could find using that quadratic formula. I could find from second calculate zeros on my calculator or some method. But if b squared minus 4ac is positive, there's going to be two solutions. Okay, your second case, the discriminant could be 0. b squared minus 4ac could equal 0. And if that happens, b squared minus 4ac is 0, so this is going to be 0. When I add 0 and I subtract 0, the problem won't change. So my solution is just going to be negative b over 2a, because this doesn't really affect things when I add 0 and subtract 0. So I'm not going to get two solutions because the plus or minus is what determines if I get two solutions. And there's just going to be one solution. It doesn't have to be at 0. It could be anywhere on the x-axis, but there's just going to be one real solution. Okay, the last thing that could happen is when I plug it in, x equals negative b squared minus 4ac could be negative. When I take the square root of a negative number, we've been talking about this a lot, okay? I am going to get an imaginary number. But negative b over 2a is going to be a real number, so we are going to end up with a complex number. Negative b over 2a plus some imaginary part, negative b minus some imaginary part. Those are complex conjugates, okay? They are not real, but there's still going to be two of them because they are going to come in pair, because we're going to add some imaginary part and we're going to subtract some imaginary part. So you're still going to get two solutions. They're just going to be non-real and they're going to be complex conjugates because it does not touch there anywhere. Okay? It's usually helpful, like I said, you could figure out what b squared minus 4ac is, see if it's positive, negative, or 0. You could look at the graph. You could tell that way also. Okay, solve this equation, write non-real numbers in the form a plus bi form. Okay, we're not going to do all of these, but we're going to do some of them. They actually want us to solve it. You could solve it by factoring. We talked about factoring. You could solve it by graphing, second calculate 0. Or you can solve it by quadratic formula. I'm going to do probably one of each because this is review. Okie dokie. Let's go with this one first, number 4. I'm going to solve this one by factoring. T squared minus 1 equals 0. This factors very easily, okay? This is t minus 1, t plus 1. That is difference of two squares. I hope you remember that. If this is a number and this is a number, when I multiply them together, one of those numbers has to equal 0. So either t minus 1 equals 0 or t plus 1 has to equal 0. Either way, when I get t by itself, my solutions are going to be plus and minus 1. Okay, the other, let's find another one. Let's do this one by graphing. 2x squared. I'm going to type this into my calculator. Minus 7x plus 15. Okay, take a look at the graph here on number 1. And if it's in your standard window, my picture kind of looks like this. And I'm sorry I can't pull it up for you because I'm not on my laptop where the TI Inspire is. It's really high up here. Okay, it's not going to touch the x-axis. That means there's going to be imaginary solutions, which means you have to use quadratic formula. That's the only way around it, okay? So we're going to find a equals 2, b equals negative 7, c equals 15. Let's plug it in. 0 is already on one side, so you're good to go there. X equals negative b, that's going to be positive 7. Plus or minus square root, b squared is 49. Minus 4 times 30. All over 2a, which is 4. 7 plus or minus. Now notice the discriminant here, 49 minus 120 is negative 71. That's negative, so it makes sense that we're going to have imaginary solutions. All over 4. Let's clean this up a little bit. X equals, you can leave it like this, 7 plus or minus I root 71 over 4. That's one way you could write it. But they said they want it in a plus bi form, so the best way to write it would be a is going to be 7/4 plus or minus I root 71 over 4. Okay, let's look at one of these that is a little messy. How about 7? Okay, 0's on one side. I'm going to look at the graph first to see if I can find the solutions by looking at the graph. 3x plus 1, I put minus, squared, minus 5. Oh yeah, it looks like there's going to be 2 real solutions here. My graph in the standard window on the TI-84 is what I have in my hand right now. Kind of looks like this. Okay, you do have the option of finding the zeros by doing the second calculate 0. And I'm actually going to do that to see, to do it twice, one for each window. And if you don't know how to do that process, you can tell me, and we can go over that tomorrow. I have x equals negative 1.078689. That's telling me that it's probably going to be an irrational number, so I am going to go ahead and use the quadratic formula. Okay. First, I'm going to clean it up because I need to figure out what a, b, and c are. Okay, this is going to be 9m squared. 3m times 1 is 3m, doubled is 6m, plus 1 minus 5 equals 0. 9m squared plus 6m minus 4 equals 0. Okay, a equals 9, b equals 6, c equals negative 4, and I really hope I don't make any mistakes here because no one's here to tell me. X equals negative b is negative 6 plus or minus square root. B squared is 36 minus 4. A times c is negative 36 all over 2a, which is 18. Negative 6 plus or minus, let's see here, 36 plus 4 times 36, oops, 180 maybe? Hope that's right. Yep, okay, all over 18. Okay, 180 can be broken down. Negative 6 plus or minus square root of, let's change this to 36 times 5 all over 18. Negative 6 plus or minus square root of 36 is 6 root 5 all over 18. Some of you don't remember how to simplify those radicals. Make sure you ask me because you will be responsible for doing that on the test. Negative 6 over 18 is negative 1/3. Plus or minus 6 over 18 again reduces to 1/3. So that's root 5 over 3. You can write it like this. Or you could write it like negative 6 plus, oh, not negative 6. Negative 1 plus or minus root 5 over 3. Either one of these answers would be acceptable. We could do more of these if you have questions. Ask me in class tomorrow, and I'm happy to go over them with you. Okay, give the real part and the imaginary part of these. These are ones we've already done. We just did some of those. The end. Okay, I guess that's all we have today, and I will talk to you tomorrow.